Welcome, folks. I see a couple of you are here. We'll get started in about 3 minutes or so. Welcome. I see we've got a few more people on. We'll get started in another 2 minutes or so. Hello, folks. Got about a minute left before we start. Welcome to everyone who's here. All right, folks, let's get started. Welcome, everybody. See if we can get this rotated and adjusted. There we go. Coming to you live from my basement. Welcome to day 18 of remote learning. Today's joke is, what do you call a cow with 2 legs? Lean beef. So happy Wednesday. Solve that like button to show your support. Lots of news and announcements today. So the first one is I'm running out of bad jokes. I never thought this day would come, but it seems to have. I've got a couple left for the next few lessons, but I'm running short. So if you have any suggestions, put them in an email, send it my way. Don't put it in the comments down below because then other people would see it before I tell it, and that's not as fun. So if you do have some suggestions, send them to me by email. Second announcement, the government announced that schools will be closed until at least the end of June. So that means that we will not be getting together as a class during this school year. We'll be finishing the course online. So that's pretty sad. I definitely wish that we'd have a chance to get back together again, but it looks like that's not going to happen. So the good news is we will finish all of the major material for the course. We're actually about 3 or 4 lessons away from doing all of the major topics. There are some additional topics that would be helpful to cover for sure. We normally do them in grade 9 math. And so we're going to get in as many of those as we can. But first, we're going to take a week once we're done all the major topics and just really reinforce that and make sure that you're comfortable with them. So when you get to grade 10 and your teacher starts to build on top of those things, that you're like, okay, yeah, I remember doing that. I know how that works. And so I'm ready to see the next steps from it. So that is really my goal, is to make sure that you are well prepared for grade 10 math. I've had a lot of questions about marks. We don't know what's going to happen at the end of the semester. We've been told that there will be some kind of report card, but it's not clear yet whether there's going to be a mark on it, or it's simply going to say you got the credit or you didn't get the credit. So my goal is not to worry about marks. It's just to make sure that you are as well prepared as possible for grade 10. Nobody is going to look at a mark from this semester and use it to decide anything about your future. So I would recommend to you that you let go of marks, forget about marks, and just worry about, okay, these are the skills. How well do I know each of these? If there's some of them that I don't know very well, take the time and make sure that we polish those up so that you're ready for grade 10, and that you go into grade 10 feeling confident and well prepared, which sets you on a good path to do well in grade 10, grade 11, and grade 12. Because at the end of grade 12, that's where people will be looking at your marks for post-secondary, for college and university admissions. So we want to make sure that we set you up well now so that you've got a good foundation moving into the future. Also, I think the math's pretty interesting, so hopefully that's another good reason for you to keep looking at it and learning it. The final announcement, Cameron Heights is celebrating its grads on Insta, which I'm told is the cool way to say Instagram. So I've added a link to the lessons. You want to check it out. It's some pretty great stuff that's going on there. So you can see where our grads are going next year, what their plans are. It's a nice way to recognize them. Usually we do that at the graduation ceremony, but who knows if there'll be a graduation ceremony this year. So we wanted to make sure that we gave them the opportunity to be recognized that way. So check it out. It's pretty neat. Some of them may be people you know or you've seen around the halls, and I think you'll enjoy it. All right, so today we are going to talk about solving a system of linear equations by graphing. Let's get right into it. All right. And we need to focus that up. That's better. All right. So in the Google Classroom, we've got a few documents. We're going to be starting with the document called day18.h, solving linear systems by graphing. The first question there is about Gino's Pizza. So you can get that one open. I'm going to tell you a little bit about linear systems. So linear systems, it's just a fancy way of saying more than one linear equation. And we've talked about linear equations, sort of the y equals mx plus b in standard form and a variety of different forms for them. But we've talked about them for two variables, usually x and y, but you could do n for number of pizzas and c for cost of pizzas, for example, or any two variables that you want. So if we have a single equation with just one variable, we know that we can solve it. So if we sub in values for the x and the m and the b, then we can solve for y. If we sub in for y and x and m, we can solve for b, and so on. If we have two equations and they have both an x and a y in them, so there's two variables in there, because there are two equations, it turns out that we can usually solve to find the only pair of xy values that work in both equations. So when we have more than one equation and more than one variable, we can solve it. So this year, we're just looking at two equations with two variables, x and y. In grade 10, you're going to see two more advanced methods for doing this. This year, we're just going to do it with graphing. In grade 10, you'll see two algebra ways to do it called elimination and substitution. In grade 12, you'll look at using three-dimensional equations, so x, y, and z, forming a shape in 3 dimensions, usually a plane instead of a line, and how to look at three equations with 3 dimensions. And in fact, we can do this with much higher dimensions. So we can do 42 equations with 42 variables in them and solve them. And the techniques are very similar to what you're going to learn in grade 10. People study this stuff in immense detail. There are entire university courses on how to solve systems of linear equations. In computer science, the area that I studied, there are entire courses on how to get computers to solve linear systems quickly. So just speeding up how fast they can solve them for large systems. And the reason is that linear systems represent constraints on real world situations very well. And so they get used a lot in economics, they get used a lot in science, in engineering, in a wide variety of fields. And so there's a lot of people out there who are really interested in how to solve them and how to solve them quickly. So today we're just starting with the tiniest little bit, solving linear systems by graphing. But I wanted you to know that we are at the start of a very deep path to follow here. This isn't just like a kind of one and done, oh yeah, that's simple. There's a lot more to this topic. You can literally spend your whole life studying this topic if you wanted to. So that's where we're at. So hopefully you've got the document open and you can see the question. Gino's Pizza delivery costs $10 per pizza plus a $12 delivery charge. Rocco's Deep Dish Pizza, their delivery costs $8 for a pizza plus $20 for the delivery charge. So what we're interested in knowing is for what number of pizzas will they cost the same? Or really a better way to put it would be, for what number of pizzas is Gino's cheaper? And for what number of pizzas is Rocco's cheaper? So if I order 12 pizzas, which one should I order from to get the cheapest deal? If I order 3 pizzas, which one should I order from to get the cheapest deal? And in a situation where you're just buying something and all you're worried about is its own cost, it's clearly the lowest one that's the best, right? So like if you go to Rocco's and pay $8 for a pizza versus you go to Gino's and you pay $10 for the same pizza, Rocco's is always going to be better. But once we add in the delivery charge, things get more complicated. So Rocco's has a cheaper per pizza cost, but if you only get one pizza and you do delivery, then Gino's is $10 for the pizza plus $12 for the delivery charge, $22 in total. Whereas Rocco's is $8 for the pizza plus $20 delivery charge, $28 in total. So Rocco's is actually more expensive to get one pizza delivered to your house than Gino's, even though the cost for the pizza without delivery is lower for Rocco's. So that's why this is a bit of a more interesting question than it might first appear. All right, so all of that said, I'm going to show you how we are going to be solving these questions today. And like I said, you can get much more complex ways of doing this, but this will be okay for now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So I'm going to remake the grid that you see there. So we have 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And going across the bottom, so that's going to be our cost in dollars. And across the x-axis, or maybe we'll call it the n-axis for number of pizzas, we have this here. We're going to go up to 15, so something like that. So 0, and I'm just going to label every second one here, 2, 4, 6, 8, 10, 12, 14, 16. So this is number of pizzas. And so the way that we're going to deal with this is we're going to graph the relation between number of pizzas and cost for both of these places. All right, so let's write it down. So Geno's, let's say our variables, let n represent the number of pizzas. Let C represent, ooh, that doesn't look like a T. Let C represent the cost, total cost. So not cost for one pizza, the total cost of all the pizzas plus delivery. Okay. So then for Geno's Pizza, the cost is equal to $10 per pizza. So if I get 2 pizzas, I'm going to have to pay $10 twice. If I get 12 pizzas, I'm going to have to pay $10 times 12. So if I have n pizzas, it's going to be $10 times n. And I pay the delivery fee, $12, and I only pay that once. Okay, if I get 300 pizzas, it's still just a $12 delivery fee. Well, maybe 300, they would change their mind. But any reasonable number of pizzas, it's just $12 delivery charge. 1 pizza, I pay $12 for delivery. 5 pizzas, I still only pay $12 for delivery. And this is going back, we talked about the weird situation where 12 is the initial value, because if you got 0 pizzas, and you were like, hey, Geno's, what's up? I want you to deliver no pizzas to my house. Geno's is like, why would we do that? That doesn't make any sense. We don't want to waste our time going to your house. And you're like, I'm not going to waste your time. I'll pay you the delivery charge, but don't bring any pizzas. Bring me 0 pizzas. They'd think you were crazy, but they'd say, okay, like if you want to pay $12 delivery charge for no pizzas, then it's $12, right? So no matter how many pizzas we have delivered, delivery charge is always $12. Okay, so this is Geno's. And then we have Rocco's, and they are doing $8 per pizza. So if we have 3 as our number of pizzas, it's going to be 8 times 3, $24 for the pizzas, plus $20 for the delivery charge. All right. Okay, so I'm going to pause it there because we've set up the things that we need. Can you give me a 1 in chat if you are feeling comfortable with what you've seen so far? And if you do have a question instead, feel free to put that up. Thank you. See, we have a Juicy Fruit Gum fan. Thank you, Owen. Thanks, Sabrina. Thank you, Jordan and Emma. All right, seeing lots of 1s. If you're typing a question right now, that's great. Go ahead and finish typing your question. I'll try to keep an eye on the chat and answer it as soon as it comes up. Okay, so now what we're going to do is we have 2 equations of lines. This first one has a rate of change or a slope of 10 and a y-intercept of 12. The second one has a rate of change or slope of 8 and an initial value or y-intercept of 20. So I'm going to use 2 different colors for these. I'm going to do Geno's in red And then I'm going to try to do the other one in green. So Geno's in red. So we start at $12, which is right about there. So for 0 pizzas delivered to my house, they would charge me $12 and think I'm crazy, but that's okay. For 1 pizza, it's going to be $12 plus 10 more, gets me to $22. For 2 pizzas, we're going to go up another $10 to $32. For 3 pizzas, another $10 to $42. 4 pizzas, it's going to be $52. 5 pizzas, it's going to be $62. And you can see we have the nice linear relation. I'm going to join it together. Obviously, most pizza places won't let you order half a pizza, so we could leave the points. But I find it's a little easier to see what's going on if we draw the line. There we go. So that one is Geno's. And then we've got Rocco's. I should write that here. Rocco's. And let's do Rocco's in green. Hopefully this pen will work nicely. So Rocco's, it's $20 for no pizzas, right? Delivery of nothing to your house, that's going to cost $20. Then $8 more for the first pizza. So first pizza is $8 plus $20. That's $28, which is right about there. For the second pizza, we have to add another $8. So 8 times 2, that's $16 plus 20, that's $36. So we've got $36 for 2 pizzas. For 3 pizzas, 8 times 3 is 24, plus 20 is 44. So it is $44 for 3 pizzas. For 4 pizzas, 8 times 2 is 32, plus 20 is $52, and that is right there on the line. And then for 5 pizzas, 8 times 5 is 40, plus 20 is 60. So we're there. And if we draw the line, and we have to be careful, get it just right. There we go. You can see here that Rocco's costs more than Geno's for 0 pizzas, 1 pizza, 2 pizzas, 3 pizzas. Costs the same as Geno's for 4 pizzas. And then after that, the lines switch, and Rocco's now costs less than Geno's. And it's going to stay that way, right? Lines are going to get farther apart. Rocco's is going to be below Geno's for the rest of it. So if you're ordering 3 pizzas, you should order from Geno's. It's cheaper. You'll save yourself $3. If you're only ordering 1 pizza, you should definitely order from Geno's. You'll save yourself $6. But if you're ordering 10 pizzas, well, Rocco's is going to be cheaper than Geno's for 10 pizzas. So by making the graph, we can see what the values are, and we can tell which one is cheaper, which one has the lower line, where on the graph. So the question asked us, for what number of pizzas will they cost the same? So we can say it right here. Therefore, for 4 pizzas, both cost $52. For less than 4 pizzas, and this technically wasn't asked in the question, but we're going to say it anyway. For less than 4 pizzas, Geno's is cheaper. For more than 4 pizzas, Rocco's is cheaper. All right. So there you go. That's how we do these questions. If you don't have grid paper at home, which I would imagine is going to be quite a few of you. So if you don't have grid paper, you may be able to print some out, and I'll add that to the Google Classroom. But if you're like me and you don't have a printer at home either, then what I would recommend doing is using Desmos to graph the lines. So you'll need to create the equations yourself, but then you can use Desmos to graph them, and you can see the point where they intersect, and you can see where one or the other is taller. So we're going to pause there. Give me a 1 in chat if that's making sense. If you have questions, now is a really good time to ask them. Thanks, Sabrina. Thanks, Owen. Thank you, Jordan, Emma, and Alan. All right, seeing lots of ones. If you do have a question, please get it into the chat. I'll get it answered as soon as possible. So we're going to go through the second example here together. This is the one about the corn plant. If you just scroll down in that same document, you'll see the one about the corn plant. It was 10 centimeters high on June 1st. Each day it grows 1 centimeter. Tomato plant was 30 centimeters high on June 1st. Each day it grows 0.5 centimeters. And we want to know on what day will both plants be the same height. So what I'm going to ask you to do first is see if you can make the equation for the height of the corn plant given its day. So let's use D to represent the day, and let's use H to represent the height. So D for the day, H for the height. Give it a try. Once you have the equation for the corn plant, you can just type it right into chat. All right, Owen. So for an equation, Owen, we're going to want an equal sign in there somewhere. So I'm not sure whether the plus sign there is supposed to be an equals or whether you meant to have something else equal to that. Do you want to clarify it? Cool. Thanks, Owen. That looks really good. Thanks, Jordan. And don't forget to get an equal sign in there so that we know what that is equal to. See if we can get a couple more. You got it, Jordan. Thanks, Alan. That looks good for the tomato. All right. So I'm going to ask you to do this one in Desmos. So you can see the two equations that we have here. We have 1d plus 10 equals h, and we have 0.5d plus 30 equals h. So if you go over to desmos.com, click into the calculator, and then you can type in those two equations. I usually try to put h equals at the left side, so at the start. It just makes it a little easier for Desmos to figure out what variables you want. All right, so I'm going to show you here what we've got from Desmos. Just make sure. Ooh. All right, Desmos. There we go. So hopefully that's showing up clearly for you. You can see over here I've got the two equations. Height equals 1 times d plus 10 for the corn, and height equals 0.5d plus 30 for the tomato. So this blue line here is the tomato. The red line represents the growth of the corn. Obviously, in the real world, these things aren't perfectly linear, right? The corn's going to grow a little faster some days, a little slower others. But in general, this is pretty close to what we'd expect. And we can see here that from day 0, which is the 1st of June, to day 40, which is going to be, I guess, the 11th of July, we're going to have the corn be shorter. And then on day 40, both plants are going to be the same height. And then beyond that, we're going to have the tomato be the shorter one. The blue gets shorter. All right. So what questions do you have about that? And if you don't have any questions, you feel like that makes sense to you, you can give me a 1 in chat. Please try it in Desmos. Make sure you can get both of those lines graphed before you type the 1 into chat. So try it in Desmos yourself. Make sure you can get both lines graphed. You see the same thing that I saw there. And then type me a 1 in chat if it's making sense, or a question if you have one. Thank you, Owen. Thank you, Alan. Thank you, Emma. Let's see if we can get a few more. Just make sure everyone's following along. Thank you, Jordan. Thanks, Sabrina. Okay. So that is how we solve linear systems in grade 9. In grade 10, you'll learn 2 other methods. Both of them speed things up considerably because you don't have to draw a graph. I just want to talk briefly about why we might not want to use the graphing method, because the graphing method is obviously pretty easy, right? We know how to graph a line, so we draw both graphs, we look at where they cross, there we go. So the first thing is this point where the two lines cross, we call that the point of intersection, or the POI. So if you see a question that asks you to find the point of intersection of two lines, we're looking for this point where they cross. Similarly, if you see a question ask for the solution to a system of equations, it's also asking for the point where the lines cross. So you want to give it the coordinates. So for this one, the coordinates would be 4. Oh, where did my nice pen go? There we go. So the coordinates of the solution to this system would be 4, 52. The point of intersection would also be 4, 52. So whichever way it gets asked for, you're trying to find this point where the two lines cross. So that's the first thing. The second thing is, why would we not want to do this for some questions? Well, there's nothing that says that this point has to be at a nice integer coordinates, right? These points can happen at like 4.00278, comma 52.991. Or it could be at coordinates 2/3, comma 8/17. So there's nothing that says it has to be nice. And you can imagine on a graph, reading 4 is really easy. It's right on the line. It's going to be 4. 52, well, we happened to be calculating each value as we went, so we knew it would be 52. But usually when we graph, we just put in a couple of points and then we draw the lines. If this was 1/3, 8/17, there's no way we would know that exactly just by looking at the graph. We'd be able to say, okay, it's between this line and this line, but how do we know exactly where it is? We don't. So this method is not very good for getting exact answers. And as you know, in math, we often want exact answers. And for a lot of practical uses, exact answers can be really important, because if we're off by a little bit, and then we use that in a bigger calculation, it can make our final answer off by a lot. So the methods you'll learn in grade 10 will get you exact answers. And that's why, one of the reasons why this method is good. It helps us understand what's going on, but it's not very precise. The other reason we might not want to use this method is, let's suppose that things worked out so that the point of intersection, instead of being at 4 on the x-axis, was at like 4,000. Well, I would have to make a pretty big graph to get out to 4,000 pizzas. And if I didn't realize in advance that it was around 4,000 and I just drew this graph, my lines would not cross on the graph. And I'd have to make the graph bigger and bigger and bigger, and then I'd run out of paper, and then I still wouldn't have found the intersection point. So when the numbers are larger than the graph, which can easily happen, then this method is no good, because you need a bigger graph, or you need to shrink your scales, and it can just create a lot of work. So that's why in grade 10, we're going to learn some better methods for this. But for now, that is how you go about solving linear systems. If you look in the classroom, there's a few documents there. Day 18 of remote learning just has a bit of an explanation of the main ideas of what we did today. Day 18.h is what we just worked through. The one that says day 1, solving linear systems by graphing, that is your homework. If you go to page 4 there are some questions. The first 2 questions aren't like a situation. So like here we had a situation with pizzas. There's no situation for the first 2 questions. They just have the 2 equations. You graph the 2 equations, you find the point of intersection, and there you go. And you can see that they've got it written in for you. So that can help you out. Oh, wait, no, sorry. I'm on the wrong page. There we go. Okay, so you can see them there, 2C and 2D on page 4. So that you just graph the 2 equations, find the point of intersection. And then questions 3 and 4, those ones have situations. So question 3 is talking about taxis. And if you've used a taxi before and paid for it, you know that as soon as you step into a taxi, there's a charge, even if the taxi doesn't move. And then there's a charge for each kilometer that you travel in a taxi. So it's very much like the pizza, where there's the delivery charge right away and then a charge for each pizza. And then the second one is hotel, or question 4 is a hotel one. That one is a little bit trickier. We have N and we have M. So question 4 is a challenge for you. See what you can do with it. If you can't solve it, that's okay. In grade 10, you'll come back and you'll see more of these that are like question 4. But I know that some of you enjoy the challenge, so there's one to challenge yourself with. See if you can figure out how that one works. All right. Thanks a lot, folks. That is it for today. I'll see you again on Friday.